Okay, so my cell phone can only take one video up to possibly 57 minutes. So it will automatically stop. I didn't realize it stopped, so we miss a little part. So here we draw the complete Venn diagram, including irrational numbers, rational numbers, integers, whole numbers, and natural numbers. At the end of the last video, you possibly didn't see the complete drawing, but the rational numbers is the right part, and the big circle represent the integers, the median circle represent the whole numbers, and then the smaller circle represent the natural numbers. And these relative relations are determined by these subset relations. Okay, so in the textbook, the author provide a beautiful Venn diagram. You can consult that diagram. That beautiful Venn diagram is on page 5. So if you don't see my ugly drawing, you can just consult that beautiful diagram. Okay, now let's see the example. So example, classifying the numbers in a set. So list the numbers in the set. So we'll have -3, 4/3, 0.12, square root of 2, pi 10, 2.151515 dot dot dot. So where the block 15 repeats. Okay, repeating decimal numbers. Okay. So this is a list of the numbers in our consideration. Then we will see first the natural numbers. What are natural numbers? 1, 2, 3, 4. They're natural numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you see 10. 10 is a natural number. And that's a unique natural number from this list. -3 is negative. Negative numbers are never natural. Okay? B, integers. Integer, this time this -3 counts. Integer can be negative, can be positive. Positive is a natural number. Negative is a negative natural number, all 0. Okay? And C, rational numbers. Rational number. All the integers are rational numbers because every integer can be written as that integer over 1. So -3 is a rational number. 4/3 is a typical rational number. 0.12, the decimal number, is rational because 0.12 can be written as 12/100. Well, simplify it or not, but this is an integer over integer, so it's a rational number. Square root of 2, as we mentioned, is irrational. Pi is irrational. 10 is a integer, is rational. And we also know that some number, infinite decimal number, but repeating, this is a rational. In the second part of a pre-calculus, you will learn a method to transform this type of number into the ratio of two integers. But so far, not at this moment, we cannot discuss it. You just keep in mind, whenever those blocks repeats, then this is a rational number. Irrational numbers. Square root of 2 and pi, they are two typical irrational numbers. Okay, square root of 2 and pi are two typical irrational numbers. Real numbers. All the numbers are real numbers. All numbers in the list are real numbers. Okay? So that's an example about the real numbers. To talk about the irrational number, it's an infinite decimal number, but infinite decimal number is hard to be applied. So we want to get some approximation. For the approximation, we have two methods. One is called the truncation. The other one is called the rounding. So what is a truncation? Let me give the official definition or the strategy, and then we will see the example. Truncation means drop all the digits that follow the specified final digits in the decimal. So truncation is a simple way. Whenever you already have a specified final digits, and you just cut it at this point and remove all the tails. So that's a truncation. And the rounding is a little bit complex. Identify the specified final digit in the decimal if the next digit is 5 or more, add a 1 to the final digit. If the next digit is 4 or less, leave the final digit as it is, then truncate following the next truncate following the final digit. All right. So we have a way to modify the final digit. If your next digit is greater than 5, greater than or equal to 5, add 1 to the final digit. If your next digit is 4 or less, you don't change, you don't modify, and then you use a truncation. All right. So first, let's see one simple example, and then we see a complex example. So example, approximate 20.98752 to 2 decimal places. Okay, so we are going to approximate the specified digits is 2 decimal places. Okay, so first by truncation. By truncation, you just get 20.98. You see the second two decimal places, and that's it. You don't do anything. You just stop at after two decimal places. And if by rounding you have 20.98, 8 you don't know if you multiply it or not. After 8 you check the next digit, it is 7, it's greater than 5, so you're going to add a 1 to the final digit. 8 plus 1 is 9, and then you truncate the following digits. So the approximation is a 20.99. By truncation it's a 20.98. All right, so that's a difference. Okay, so now let's make this practice longer. So we are going to have 3 numbers. A is a 3.14159, and B is 0.056128. C is 893.46125. So we have 3 numbers, random numbers, decimal numbers. So the first requirement, round it to 2 decimal places. Round it. You see here, first one, it's a 3.14. 3.14. 4 you don't know. Whenever you see round, you don't know if you change the specified final digits or not. 4, next digit is 1. It's a 4 and less, so you don't change it. You don't modify the final digit. And for this second number, number B, 0.05, so this is second digit decimal place. But next one is 6. 6 is greater than 5, so it's a 0.06. 5 plus 1 is 6. 893.46. 466. The next digit is 1. 1 you drop it, so it's still 6. Okay? So round it to 4 decimal places. 4 decimal places, let's check it. It's a 3.1415. 5 is the final digit, and its next one is 9. 9 is bigger than 5, so you add a 1. 3.1416. And here, 0.056, the final digit is 1. Its next is 2. So 2 is smaller, you drop it. And this one, 893.461, the final digits, 4 decimal place, the final digits 2. Its next is 5. 5, you add 1 up, so it's a 3. You see the next digit is bigger, add 1. If you see the next digit is smaller, truncate. If you see truncated to 2 decimal places, truncation, simple. You just read 3.14. I don't care the next digit. 0.05. 893.46. That's it. So just ignore the rest of the decimals. Truncate it to 4 decimal places. 4 decimal places. 3.1415. Okay, you just count 4 decimal places. 0.0561. A9 3.461 and 2. Okay, and that's it. So truncation is much simpler and faster than the rounding up or rounding off. All right, so that's our idea. Okay, so next subsection of this part is a calculator. So here let's make this policy clear. Calculators are not allowed in exams. So here this calculator means whatever type of a calculator, or the software on the computer, or the TI machine, Texas Instrument, all the type of calculators are not allowed in the exam. Okay, so I'm not going to discuss any operation on a calculator. You know it or you don't know it, it does not matter. You cannot use them during the exam. All right, okay, so we finish Tuesday's class now, and I suggest you to do the corresponding exercise. If you have question, send me email. If you have any question about the courses or have question about any part related to the classes, send me email. I will try my best to answer your questions. All right? Okay. See you next time. Bye-bye.